If you try to train a modern AI model using a standard computer processor, it would literally take thousands of years. The math behind AI is simply too massive for normal computers to handle efficiently. That is why the tech industry depends on two specialized hardware accelerators, GPUs and TPUs. But what is the actual difference between them? Here is the simple explanation in exactly 4 minutes. Let's start with the GPU, or graphics processing unit. A normal CPU is like a master chef in a kitchen. It is extremely smart and extremely fast, but it usually works through tasks one at a time. Open a browser tab, load a file, run a spreadsheet, switch apps. CPUs are designed to handle lots of different jobs reliably and in sequence. A GPU works differently. A GPU is like an army of thousands of line cooks all working simultaneously. Instead of one powerful worker doing tasks step by step, you have thousands of smaller workers doing the same operation at the same time. Originally, GPUs were built for video games. Rendering graphics means calculating millions of pixels across your screen instantly. Every pixel needs math. Every frame needs more math. So engineers designed GPUs for parallel processing, meaning huge numbers of calculations happening simultaneously. And by coincidence, AI training needs almost the exact same thing. Training a neural network is mostly giant waves of matrix multiplication. You feed data into the model, multiply massive groups of numbers together, adjust weights, then repeat the process millions or even billions of times. GPUs are perfect for this because their thousands of cores can process enormous batches of calculations all at once. That is why NVIDIA became such a dominant company in AI. GPUs turn out to be the ideal hardware for modern machine learning. But then Google asked a different question. What if you do not need flexibility? What if you only care about one type of math and you want to do it as efficiently as physically possible? That led to the TPU, or Tensor Processing Unit. Unlike GPUs, TPUs were designed entirely from scratch for AI workloads. A GPU can still render games, edit video, or run graphics software. A TPU is much more specialized. Its main purpose is accelerating matrix math for neural networks. The key idea behind a TPU is something called a systolic array. Think of it like a giant automated factory conveyor belt. In many chips, data gets calculated, stored in memory, pulled back out, calculated again, then stored again. That constant movement wastes time and electricity. A TPU reduces that overhead by passing data directly from one calculation unit to the next in a continuous flow. The numbers move rhythmically through the chip, almost like a heartbeat. Instead of repeatedly stopping and restarting work, the math keeps flowing forward. That design makes TPUs extremely fast and extremely energy efficient for large-scale AI training. So which one should you actually use? GPUs are the Swiss Army knife. They are everywhere. You can buy them for your desktop computer, rent them from almost any cloud provider, and use them with nearly every major AI framework, especially PyTorch. They're flexible, widely supported, and beginner-friendly. TPUs are more like a surgical scalpel. They mainly exist inside Google Cloud and work best with Google's AI ecosystem, especially TensorFlow and JAX. They're less flexible, but at enormous scale, they can reduce cost and power usage significantly. For most developers, startups, and students building AI applications, GPUs are the default choice because the tooling and community support are massive. Companies usually move toward TPUs only when they reach hyperscale training workloads. So now you know the hardware power in the AI revolution, but there's another major concept that confuses people: the difference between teaching an AI and talking to an AI. Those are called training and inference, and they require completely different kinds of computing power. Click the next video to see how that works.